Welcome everybody to this month's Interoperability and Technology Tech Dive webinar series. I just like to start out by welcoming newcomers if you haven't been here before. If somebody sent you this link and told you about the call, you can get on the mailing list by going to this page here, which I think Annie's going to chat into the chat window there. And you can click to join here, and then you'll get notified of future webinars. And if you click this link here, it'll take you to the webinar page where you can see all of our previous recordings, and all of our talks are recorded, including this one. And so if you missed something, in fact, actually last month we had a talk that was given in person at the ESIP winter meeting that I've posted here. So you probably haven't, if you haven't seen this one, really check it out. The Pangeo project is very cool. And actually, so today's speaker, Craig Willis, talking about the National Data Service Labs Workbench, I found out about this through an ESIP incubator project that we proposed and got funded. It was led by Sean Gordon, and about 5 or 6 people. And it was a proposal to create a Jupyter Hub instance that could be used for ESIP meetings to help people run workshops and have a common environment set up. And we found out about the National Data Service and that they have similar capabilities and some similar goals. And so we thought it would be a good thing to hear more about the National Data Service Labs Workbench. So Craig Willis from NCSA is going to give us today's presentation. So Craig, I'm going to just switch it over to you and make you the presenter. So you should be able to share your screen now. And you can take it away. Looks good.
I think you had asked, do you want video or no?
Oh yeah. You want to pop the webcam just to say hello? That would be good.
Well, I am in a very nameless conference room. Hello.
Hi, Craig.
You are no longer seeing the presentation that I want you to see. All right. So yeah, thanks for the opportunity to present here today. Yeah, we all kind of met through this ESIP lab pilot, and yeah, I guess this is part of the MOU between NDS and ESIP, is exactly this kind of a thing, to have the opportunity to share information. So my name is Craig Willis. I'm research programmer at the National Center for Supercomputing Applications in Champaign, Illinois, or Urbana, Illinois, and I'm also now the technical coordinator for the National Data Service Project. And I'll be talking a little bit about the NDS, more about this service that we created called the Labs Workbench. I guess here, what is the National Data Service, an overview of some of our services, particularly the Labs Workbench, and I'll give a quick plug for a workshop that we ran here last year, just for those interested. So the National Data Service is kind of an interesting group. It was best characterized to me at an RDA meeting by one of the executive committee members, saying that it's not really national. It doesn't have national support. It's more of a consortium of like-minded folks who had come together at some point. And there was an earlier effort really among the supercomputing centers to come up with really a national data service, something more in line with, say, EUDAT or some of the big national services, Australia, etc. But as that vision is continued to come to fruition, the NDS as an organization has functioned as more of a consortium, running some annual meetings or biannual meetings. And then there was a bit of a core organization. We've gone through a recent restructuring and all. So while there was a consortium that we had workshops and consortium meetings, that is no longer happening right now. And NDS is more or less being defined by MOUs with some of the bigger kind of research data and research data management oriented organizations such as RDA US, ESIP here, the Midwest Big Data Hub, and the other actually big data hubs, and EarthCube. So the NDS core organization is split between San Diego Supercomputing Center and NCSA. There's a steering committee and a technical advisory committee. And I think much like maybe the ESIP labs notion, that NDS through these like member organizations, and particularly STSC and NCSA, has provided support for pilots, and this includes storage resources, compute resources, human resources, and assignment of developers to projects, et cetera. And NDS has often been touted as kind of a builders consortium, less so kind of to differentiate from RDA, which is often more concerned with, say, governance or policy and protocols and standards. NDS was really more towards the implementation or kind of facilitating the building of cyber infrastructure services related to research data. So, and this content, a lot of this is available on the website, which I did not link to on that previous slide, but should have. So NDS has really one primary platform. There's another in the works that is a little less traction right now, the Workbench, which I'll demonstrate here and go into greater detail. And NDS hosts the Workbench service for workshops, hackathons, tutorials, and then we also offer piloting services, and these are typically through OpenStack cloud resources. So in the context of this ESIP collaboration with the group that Rich is involved with, we'll be providing some resources through SDSC Cloud, which is OpenStack, yes, virtual machines, and some Swift storage. And along with piloting services, NDS offers collaborative support, which is, in the context of this ESIP project, me and others participating in that project to share information and to learn from what's going on. Another service we offer is, I guess, through the NDS membership, is data hosting. So it's for data sets that don't have a place to live, and this is really part of the vision of NDS Share as a kind of repository of last resort. And these tend to be things that don't fit our typical research data management infrastructure, projects that are important but have lost funding, that are large, that can't go into a traditional repository. And I can give a couple of examples of those in a minute. So the NDS Labs Workbench was an NDS initiative that started in January 2016. It was intended to be a scalable, community-driven platform, really originally for web-based access to share and discover data-related tools. So the idea was really from a lot of these data infrastructure projects that are building reusable proof of concepts or actual reusable products, that we can all more easily discover each other's work and decide whether to deploy it or not in our own environments. It's evolved since then to actually serve as a platform to provide remote interactive access to data, a la something like Jupyter Hub, and kind of in the same vein, that by providing web-based access with these consistent environments via Docker technology, we can now support things like workshops, training, hackathons, et cetera, pretty easily with the same platform. The link up there at the top is the beta instance of this service. That's really just kind of a kick the tires for anyone interested. That's hosted at SDSC, and I'll actually show it here shortly. I don't know how familiar everyone is with containers, but it's kind of an important concept with Workbench itself. So containers, and we're talking Docker primarily for us, but also Singularity and Shifter and HPC environments, is in some ways a lightweight VM. It's a way to package code and dependencies that's runnable in a lot of different environments. They're lightweight, that provides nice isolation. And you see this trend all around, one for IT and system deployment. It just makes it easier to run services, packaging of research software, and so getting an entire research stack in a way that anyone can run anywhere, which now leads to the potential for reproducibility. So these containers, which probably everybody has heard a fair amount about, have a lot of traction. We're providing access to research data, we're providing reproducible kind of research software packages for the reproduction of research, but also blurred with this idea of more efficient deployments. Very, very high level overview of the Workbench service itself. So we kind of attached ourselves to Kubernetes, which is a container orchestration framework. We always run on OpenStack right now, just because all of our resources are made available through places like SDSC Cloud, NCSA Nebula, Jetstream allocations, but we do have an intent to move towards commercial environments. And
Craig, can I break in with a nerdy question?
Please.
Somebody asked me this morning that, why do you run Kubernetes on OpenStack instead of on bare metal? Is that?
Well, because we don't, in terms of the NDS project, we actually don't have bare metal resources available to us right now.
Oh, okay.
So that's, I think everyone would prefer to do it, given some of our experience with OpenStack environments that we've had access to. But it's, the allocations that we have to run this service typically are on Nebula or SDSC Cloud or Jetstream. So there's no reason you can't run it on, obviously Kubernetes on bare metal, but it just so happens that in our environment right now, this is just what we have.
Right. Yep. Okay, thanks. Oh, and by the way, if anybody, actually Craig did say that he doesn't mind being interrupted for questions. You just have to unmute yourself because we've muted folks. Does anybody else have a question actually at this point?
I'll just roll on. So
yeah,
Workbench itself is actually a pretty thin layer over the top of this. There's an API server, REST-based API server, a UI. We take advantage of the Nginx load balancer that's actually now part of the Kubernetes ecosystem. And there's a catalog of services that's stored in effectively JSON data. And we leverage a whole bunch of other services that have already been containerized, and we find ourselves containerizing a lot of applications that haven't. So our core services run in one space. We take advantage of a lot of system services for monitoring, registry cache, logging, kind of the traditional logging monitoring stacks, and then users can run their own applications in this environment. I've lost the big move there. So, tragic. I wonder if I lost a slide. So there are, actually, no, it was up at the top. There are kind of three main use cases that we have right now, and actually the first one is the one I'm going to present last, and I'll go through the others here. So collaboration on complex data projects. This is the one that's kind of the most interesting to us right now, and we've got a couple of use cases that Workbench has applied in this case. So you've got researchers, potentially independent data scientists, and you've got software developers working on a project centered around a very complex data set, very large and complex data set. And all of them need remote interactive access to the data, but they all have kind of different requirements as to how they access that data. Researchers like their kind of Jupyter and RStudio environments, developers want IDEs, data scientists maybe more similar to researchers want some of these other environments for analysis. And the data is complex enough that the software environments have complex and changing dependencies. So it's really hard to keep up to date with all of the moving parts. And added to that, that if you're a research programmer like me, and you're on a bunch of different projects, it's really hard to keep on top of all of the changes for this type of a project. So Workbench is moving in the direction of kind of solving this problem. So our primary use case right now is the ARPA-E TerraRef project, and this is a big petascale, high throughput plant phenotyping project that's in part out of here and out of Danforth in Missouri. And we've got the data processing workflow, raw and derived data. It'll be upwards of 2 petabytes in the end. And it's a multi-institution national collaboration. And so Workbench for this project actually provides remote interactive access to the data by collaborators and developers. And so just some screenshots here, and I'll go into a quick demo. There's a catalog of tools. In this case, we've got a Python IDE, Postgres SQL interactive web interface, RStudio server with all of the Terra dependencies, Jupyter environment as well, and then some X Windows applications. And users can just launch these things in Workbench to access the data that's stored on a big shared GPFS file system, or some of the project data is also stored in Mongo databases or Postgres databases that they can access directly as well, without having to go remote other than through the browser. So if all goes well, these are here for me. Actually, I'll preface this a little bit. So here is the beta Workbench instance that's hosted at SDSC. This is kind of the main kick the tires instance with a big catalog of tools with everything from CCAN to Cloud9 IDEs to Dataverse to an iRods environment. It's got the kitchen sink in here. The TerraRef instance is hosted at NCSA as a part of their kind of project allocation. And it's got that smaller catalog of just tools and dependencies for Terra. And so I've got a Cloud9 environment where I'm now browsing, in this case, a read-only copy of that, what's probably just under a terabyte of kind of raw and derived data from their pipeline. I've got a Jupyter environment that's got a set of tutorials that I can run through to understand the data. Similarly, in our studio environment that's got mounted that exact same set of tutorials for our user. I've been logged out of my session here, but a Postgres environment to interact with one of the core trait databases that they use. And then this horrible but necessary Expert environment for applications that I might want to use remotely that are strictly X desktop. So in this case, QGIS. Similarly, I've got the data mounted to where I can go browse some of the GeoTIFF data that comes from their system.
Cool.
And I'll throw just a quick look up here that there's a repository of Docker files that support some of these images. So we'll see, let's go see the Jupyter environment that is your usual Jupyter. Oh, this doesn't look right. Oh yeah, but it's got, in this case, some NetCDF, GDAL dependencies added to it, and I think R as well, and then that Expert environment, which is also somewhat of a kitchen sink for an NCO environment that was used by one of the developers working on their hyperspectral pipeline. And so these are all auto-built into Docker images that are then used by the system. I think I'm doing okay for time. Case number 2, so workshops, trainings, and hackathons. And this was one of the first cases that the Workbench was used for out of the NDS group. Is immediately a collaborator at the University of North Carolina wanted to run a Dataverse tutorial at a conference and needed a way to launch 35 instances of Dataverse for his participants. And we've since used it to run several different workshops, many of which are actually affiliated with the TerraRef project. And you've got these pre-configured environments on Kubernetes, so it scales out pretty easily. The data and software are all right there. The participants don't need to install anything, and you don't have to worry about hotel Wi-Fi, et cetera. And then it even works on tablets most of the time. And so we've got the PI4 bootcamp. This is, I'll go into detail here. We helped with a hackathon for Think Chicago, a civic data challenge. We run a tutorial server for the Einstein Toolkit community as a part of the Terra project. One of the PIs of that project ran a workshop at a Phenome conference. We ran a class for the University of Washington, an Intro to Data Curation course where students got direct experience with the CCAN, and then we'll be supporting the Data-Driven Ag workshop run by the USDA here at the end of the month. So that's the first case here. So this is co-organized by the TerraRef team, up to about 50 participants accessing the TerraRef project data, some additional satellite imagery, and they want those environments, plus they need a GeoServer instance to serve some of the satellite data that we'll just deploy. In this case, we'll just deploy into the underlying Kubernetes system outside of Workbench itself. PI4 was a 2-week course for math graduate students at the University of Illinois here, also co-taught by that TerraRef PI and computer science faculty for 35 students in an intensive course running through kind of computational data analysis methods using effectively Jupyter and our studio environments with with some of the common tutorials from the TerraRef project. So then the original purpose of Workbench itself was sharing and discovery of data tools. And we pitched this to the EarthCube community as a way to kind of host and preserve some of the building blocks coming out of their system. As they fund the construction of these building blocks, and being able, for those of us in this community, to be able to kind of see those in operation quickly and be able to launch them and interact with them to evaluate them, we thought would be handy. And then we do this in our beta system as well. And so this is You've got a catalog of tools that your users can come and deploy into a private sandbox easily. Yeah, and this is an oddly placed slide for a use case that we're working with researchers at the University of Nebraska that are in the bridge health community to host a database of bridge infrastructure data, and then an example environment, which is basically a Jupyter environment with notebooks for analysis, so their community can come and see how it's actually to help their community to understand the value of things, in this case like Jupyter notebooks and sharing research data and environments. And I had a duplicate. So whirlwind tour. A couple of current directions. We've recently released kind of 1.1 that's got a quick start function, and the intent of this is in the next slide here. The ability to have a link that allows a user to just click on that link and launch an environment in a Workbench instance running somewhere. So this is a little bit, if you're familiar with Binder, the idea that you could plug a link into a GitHub repo or into even to a metadata record in a repository to allow a user to spin up a container and that's got the environment plus potentially something like shared notebook or shared data running through the registration and approval process if needed.
Is this actually? Sorry, is that actually you running your own Binder service? No. No.
I've just kind of used that as a metaphor.
Okay.
When you effectively, if you click on this link, if you can see what's under there, this is the NBI example. It'll go out to the Workbench instance at SDSC that has that environment with the NBI data hosted in the Mongo database over there. And it spins up via Workbench, via Kubernetes, the associated image and returns to you the running environment, which in this case just happens to have an example notebook in it. But there's no, this is, I wish we were more tightly, I guess, following or coupled with the Jupyter Hub community. We kind of developed this independently, but we support obviously things outside of Jupyter, but Jupyter is so widely used, it's one of our primary examples.
Yep, okay.
So OAuth 2 support, focusing on right now Global Auth and CI logon, so that would just give shibboleth support within the academic world. And the integration with Spark and HPC clusters. So one of the problems we've faced, and I'm going to jump ahead a few slides, is you can do toy analysis in these containerized environments. That's handy, but what happens when you actually want to do real analysis on something like a petascale data set? And so in conjunction with the TerraRef project, we've been looking at how we can combine Dockerized images on Workbench, Singularity images running in HPC systems to where you might be able to, say, do some work in Workbench and then kick off analysis at a larger scale in a traditional kind of batch cluster. And we've done something similar with Zeppelin just as a proof of concept, talking with the Spark cluster. And as a part of this pilot, the ESIP lab pilot with Rich and the group at NCAR, we're learning about Angio and their work with Dask that looks super compelling for this kind of solving the same problem. Boom, quick start. And that quick start link, I'll just give a plug here for what is a vision that came out of the NDS consortium, an unfunded initiative of something called Data DNS. And this idea is the bringing your compute to the data of these large research data sets. And the examples here are 3 very large astronomy data sets hosted at SDSC via the YT service here at NCSA. And actually that last one is now also at SDSC, which is a big 300 terabyte data set that came off of Blue Waters. But bridging the kind of research data publication, I've got a metadata record that describes this data set with the ability to actually launch running analysis via a sample in a notebook environment and have it run at that site. And if you go back to the quick start function here, this is a step in that direction that, say, for instance, this Jupyter NBI environment might run at SDSC, but if I have a TerraRef link here, that would run at NCSA and TerraZone environment. help connect these kind of disparate services. Was there a final point on that slide? Oh, yeah, just kind of simplifying our own installation. So this is a crazy slide, but it's one I'm working on, which is something we're trying to keep this all together, which is a consistent environment that makes it easy to deploy stuff from an IT perspective on top of kind of large, complicated research data projects. You've got a gateway in the works here. If it scales well, it provides a really nice environment for education and training. So you can scale out, the same environments you use for development or to enable reuse on some of these large projects, you can now scale out to support education and training in those same environments. And you're in the kind of tutorial workshop space, the users benefit from actually having access to the real data that is the research project instead of kind of toy data. So we're increasingly seeing this kind of as just kind of one big cycle, that the same environment can be used to support all of these functions. Super nascent for us still, though. And yeah, so that's kind of the end of the lab's Workbench presentation. I'll give a quick plug here just because this is, we see Workbench is coming out of a broader trend, which probably a lot of folks are familiar with, is that the use of these container-based, either interactive or non-interactive environments for research computing and research data access. We hosted a small workshop here in August. There's a report available from that. But there are a lot of groups, either from within the Gateways community, the SciServer group out of GHU, there's the Wholetail project that's working in conjunction with Data One. There are a lot of different platforms that are following this same sort of model. Obviously, the whole Jupyter ecosystem fits in there as well. So it's, as it shakes out, I'm very interested to hear what people are doing, and so we're not repeating existing work. And that the Pangeo introduction's been great for that. I look forward to learning more about it. So.
Great. All right.
A breathless 28 minutes. So.
Yeah. So I have a question. If I'm looking at the folks on the call here. So I know that like Sophia Liu, USGS here, does a lot of like hackathon civic stuff. If so someone like her wants to use this, wants to host a workshop, what do they do, or how does that work?
Yeah, so I guess there are a couple of ways to go about this. So the NDS website, let's go there right now because I have control. One would be to contact me and see what we can do. Let's go to the actual website and not with. Wow, did I do something wrong here, or is our website down?
As you're sorting that out, I'll just follow up with thanks, Rich, for asking that question. I was kind of curious myself because these types of tools are definitely valuable during these very short, few hour kind of engagements with different members of the public to develop prototypes. So yeah, it's great to learn more about how we can leverage these tools.
So Workbench hosting is something we're working out right now. So the Ag Data Hackathon, because the PI is somebody who I work with closely here, or one of the PIs, they came to us, he wanted to use the TerraRef system to run their hackathon. It ends up that it might be better for us to host that elsewhere, just to make things easier for everyone. And so we're working out a pricing strategy for that in terms of how an external organization would pay for that kind of service through NDS. But we also offer NDS pilots, which is this pilot project application, and we've done that for collaborators like the Einstein Toolkit to help us flesh out how we support workshops of this type. As we become better at it, I'm sure it will formalize. So submitting a pilot project application will get you there. Reaching out to me directly via email on this slide will get you there. in general, they've come kind of organically through the NDS consortium or through existing projects. And I'll come back to the list of things we've run. Yeah, I think probably the Einstein Toolkit School was one of the, Einstein Toolkit has a big faction here at NCSA, so it came somewhat internally. The Data-Driven Ag Workshop will be one of the first real external projects as we work with the group at Danforth to get going. So it was a very, very long-winded answer to say we don't have a super clear path, but either submitting the pilot project application or reaching out to somebody like me, we'll see what we can do. The hackathon space and workshop space, I mean, this ESIP Labs project is exactly the same thing. There's a big need for it. And we really hope to kind of keep down this path and make it as simple as possible. And I'd like to see us, as through the ESIP pilot, extend beyond our own Workbench application, but things like hosting your Jupyter Hub instance for a workshop or ESIP in the summer. That seems like a good case where you're taking advantage of SDSC cloud resources and knowledge from within this community on how to run this kind of stuff. The other is that these are all open source tools and groups can always try and install it themselves and come to us for support. It's complicated enough right now that we tend to do it. But as we simplify that, you know, it's depending on the scale of the thing that you're running, we have reasonably simple install on OpenStack right now. But the bigger it gets, the harder it gets, I think.
And I guess another benefit that people could use right now, perhaps, is just some of those Docker files, I suppose.
Exactly, yeah, and or some of the patterns for that. But yeah, the Docker files are there. I think actually there's an interesting one is, we originally ran the, this was John Crabtree at UNC's workshop for Dataverse, which is a kind of traditional data repository. And Dataverse was not containerized at that point. And we did kind of a, not a great job, but a first pass at containerizing the whole Dataverse application. And about a year later, their development team, that became a core thing for them, and they built on what we had done and kind of took ownership of it. So we found ourselves doing a lot of work to create images for the community, but we're always happy when folks either bring their own or take that away from us so we don't maintain it.
Yeah. Does anybody else want to ask? Actually, there's a question in the chat. It looks like did you see this? The failed attempt was to because you had a HTTPS on the front there.
Yeah, well, that was my failure. So the website itself is just HTTP. That's hosted at NCSA. The Workbench instance should be HTTPS at this point.
Okay, all right.
A technical detail that some might be interested in is that the nature of the beast here is that we're require wildcard SSL certs. That's probably one of the more annoying things about the service right now. I know Let's Encrypt is betaing their wildcard certs, but every time you launch an application, you get a distinct URL. And if you're, effectively we need a cert per service that gets launched per user. Let's Encrypt has some throttling. We use NCSA's own signed certificates because we get them for free here. But that's just if you set this up for yourself and you want TLS, SSL on the services, that's a current inconvenience until we've got it working with Let's Encrypt.
Okay. What's your, you might have mentioned this, but what's your relationship with TerraRef exactly?
So yeah, it's a complicated one. So I am a staff at NCSA within the ISDA group. I actually work on the TerraRef project. It was an early NDS pilot, and what that NDS started in a weird way at NCSA as a kind of a shared pool of staff that cross-pollinated across projects to bring information about those projects back to the NDS community, essentially. But so they are a pilot in name. They're one of our main use cases for Workbench because they had a need for this kind of a thing. And so we deployed and kind of extended Workbench to fit their needs. They're also run out of, in part, University of Illinois, that at least the compute pipeline is here. So they're co-located with us. And I'm on the project part-time.
Okay. Anybody else want to ask anything? All right. Well, I'm going to ask one last question. Have you done anything with Kubeflow or Kubeflow? I don't know how you pronounce it.
No, I have not.
Kubernetes, the machine learning toolkit for Kubernetes.
No, I haven't.
Okay. Just curious.
Is it?
I guess Google has been, pushing this, and I don't know. It just seemed like, yeah.
Rich, this is Salimon.
Yeah.
I have a question. He did mention something about the relationship with Data One. Does this system now ready to extract data from Data One?
Pardon me. No, this system is not. It doesn't have a tight coupling with Data One in any way. What I glossed over there was a series of similar services that have emerged in the last few years, one of which is Wholetail, and I'll bring that up. This is an NSF-funded project that we are loosely affiliated with, and Wholetail runs, it's effectively the, let me see if I can log in, I'll demonstrate. And this is not Workbench itself, this is just me information sharing, so it's got a dashboard. Nope. They're in development right now, so this is me doing a bad job of demonstrating their system. If I can get up. So Wholetail is really about capturing the entire kind of a reproducible environment, the data plus the kind of code or notebook, etc. They are also running in a containerized environment. They are working on integration with Data One to where you can actually just kind of launch, I think you can publish what they call tails back into Data One, and you can pull data from Data One into their environment. So NDS, Workbench doesn't have anything directly to do with Data One. Wholetail, which we're kind of looking at as, they're not quite a peer service, but they do something similar in terms of launching notebooks in our studio environments and custom development environments and for reproducible science is. And I know they actually, Data One is one of the kind of key use cases for the development of this service. I think this is, they're still largely under development, and it's unfair for me probably to show it other than just to get the word out as to what they're doing. So sorry for muddling that. That was not intended to show our relationship with Data One.
It's interesting though, yeah. It's amazing how many different sort of collaborative workspace, kind of reproducible workspace kind of environments there are out there, I guess.
It's really scary, yeah.
Yeah. All right. Well, okay, one last chance. Anybody want to ask one last question? If not, okay, going once, going twice. Okay, well, Craig, thank you so much for giving this overview today. This looks this is really cool stuff here, and I think I think I'm personally going to get something out of that by looking at your Docker files for sure, and hopefully people like Sophia can figure out a way to take advantage of this, you know, for doing some hackathon stuff. And anyway, it's I think we'll be collaborating in the future, surely, with ESIP.
Yeah,
you guys are a partner.
Awesome. Okay. Well, thanks for the opportunity to present today.
All right. Take care. See everybody in a month.
Yep.